So these are the check your understanding problems for 5.3 and 4. And for number 1, we want to know where G is increasing, meaning we are looking for places where, not F, where G prime is going to be positive. Okay, so let's go ahead and find our derivative. So G prime is equal to 300 minus 3x squared, and we are setting this equal to 0. I'm going to go ahead and divide by 3. So we have 100 minus x squared, which I can factor as 10 plus x times 10 minus x. You can do that in 2 steps if you want. It doesn't really matter. Or you could move the 3x squared over, divide by 3, take the square root. If you do it that way, it's not my recommended way for 2 reasons. Number 1, if you leave everything factored and equal to 0, it's a lot easier to do test points. So it saves you a little bit of algebra. And number 2, if we move the x squared over and take the square root, then we run the risk of forgetting the plus or minus. And so to avoid that, I would really recommend that you just factor and leave everything on the left. So anyway, this is the way that I have it. So x is equal to plus or minus 10. So those are my critical points. And so I'm going to test on the number line around them, and I'm testing the sign of the first derivative. And even though I'm using this sign chart here, it really does not matter if you label it or not, because it is like on any kind of justification free response question, an AP reader is not even going to look at it. So it's really just kind of your scratch work. So it doesn't really matter how thorough it is, just as long as you can use it to draw your conclusions. Okay, so I'm doing test points, and I'm testing the sign of the first derivative around -10 and +10. So I'm going to start by some number that is to the left of -10. And I honestly don't even have to come up with an actual number. I can just say something smaller than -10. Well, smaller than -10, 10 plus something smaller than -10 will be negative. 10 minus something smaller than -10 is going to be positive. Gives us a negative product. And then if I move to the other side of the -10, then that means I'm going to have a positive here. So this factor right here will change signs. This one is still positive. So then we have a positive product. And if I move to the right of -10, then I'm going to have something bigger than 10. I'm going to have a positive here, but this one will switch to negative. So that becomes negative. And if you didn't follow that and you would rather actually use real numbers and say, okay, I'm plugging in -11, I'm plugging in 0, I'm plugging in +11, that's fine. I'm just trying to save some of the arithmetic because all I really care about is the sign. All right, so what I have determined is that my derivative is negative, then positive, then negative. So that means that the intervals where G is increasing is in between here. So I'm going to say, G is increasing on -10 to 10, and I'm justifying by saying because G prime is greater than 0, and that's all I need. If you want to write this with a closed interval, that is fine as long as the function exists at both endpoints. For increasing and decreasing, you can use open or closed intervals. I prefer to write my intervals as open because for concavity, I need to use open intervals, and so I avoid using the wrong kind of endpoints if I just always do open intervals. All right, then for number 2, here we have h of x equals e to the x times cosine. It says our domain is 0 to 2 pi, and we want to know on what intervals is h decreasing. So now we're looking for places where h prime is less than 0, okay? So let's find h prime. We are going to have to use the product rule. So h prime of x, e to the x times cosine x minus e to the x times sine x. I'm going to set this equal to 0. I'm factoring e to the x out, so I have cosine x minus sine x. E to the x can never be 0, so I really don't need to worry about this factor at all. To solve this part, I just need to know where are sine and cosine equal to each other. And on the interval from 0 to 2 pi, that's going to happen when x is equal to pi over 4, so in quadrant 1, because they're both positive right here at 45 degrees, pi over 4, and then also in quadrant 3, they're both negative, so that's going to be at 5 pi over 4. Okay, so on the interval from 0 to 2 pi, those are the only 2 places, and I want to know where h is decreasing. So I'm going to do test points on the number line around pi over 4, and 5 pi over 4. Okay, once again, testing the sign of the first derivative. I don't care about the e to the x. I really only care about this part right here. So if I plug in something to the left of pi over 4, and I'm going to use numbers here since this isn't quite as intuitive. So if I plug in something like 0, which is smaller than pi over 4 and is on my domain, if I plug in 0, cosine of 0 is 1, minus sine of 0 is 0, so that's going to be a positive. If I plug in something in between pi over 4 and 5 pi over 4, we could use pi over 2 or pi or whatever you're comfortable with. I'm going to use pi. We'll just use pi. Okay, pi is in between those. So cosine of pi is -1. I'm going to move down here. -1 minus sine is 0. So now we have a negative. And bigger than 5 pi over 4, something like 2 pi, we're back to 1 minus 0, so positive again. So on what interval is h decreasing? It is decreasing. So h is decreasing on pi over 4 to 5 pi over 4. And again, I'm going to use an open interval. And to justify, because h prime is negative. I don't need to say, I don't need more words. Sometimes students run the risk of losing points or even missing a point because they want to give way too much explanation. Don't use more words than this. Don't say, when the derivative is negative, then the function is decreasing, and then say it's decreasing on pi over 4 to 5 pi over 4 or something like that, because that doesn't actually answer the question, because you're not tying those two things together of the derivative being negative and decreasing on that interval. So don't give a like when type of situation, just give here is the interval where in this case the function decreases, reason because derivative is, and then whatever sign, in this case negative. Okay, for the next one, f is a twice differentiable function. We're given f prime. We're looking for critical points of f in the open interval from 0 to 2. So let's start there. Critical points would be where f prime equals 0 or does not exist. Okay, I've heard that a couple times by now. So our derivative is given, and we can set that equal to 0. So sine of x minus 1, setting this equal to 0. Sine is a continuous function. There's nowhere that it doesn't exist, so I don't care about that part. But it is equal to 0 at 0, pi, 2 pi, etc. So I want to know what values for x on the interval from 0 to 2, open interval from 0 to 2, would make this equal to 0 or pi, etc. So if I said x minus 1 equal to 0, then x is equal to 1. That's inside this interval. If I said x minus 1 equal to pi, I'm going to be outside the interval. So x equals 1 is the only value here. Okay, now to determine whether we have a relative max, min, or neither at x equals 1, I'm using the first derivative test, and I want to know, is my derivative changing from positive to negative? That would be a max. From negative to positive, that would be a min, or not changing signs. Okay, so checking to the left and the right, plugging values into my derivative function. I'm going to label this f prime equals. Okay, so let's plug in something to the left like 0. So sine of -1, I do know, let's remember what the graph of sine looks like. Okay, if I plug in something that is negative, but just a little bit negative, so this is negative, this would be negative pi over 2, this is negative pi. Okay, and then here's positive pi. So if I plug in 0, I get sine of -1. -1 is between 0 and negative pi. I don't really care where in here it is. I just know I'm going to have a negative value. And then if I plug in something bigger than 1, like 2, okay, sine of 2 minus 1 would be sine of 1. That's going to give me something over here, right about there, but it doesn't really matter. I just know it's less than pi. Okay, so if we are changing from a negative derivative to a positive derivative, that means we have a minimum. Okay, so I'm going to say f has, and this one doesn't ask for justification, but I'm going to go ahead and write it for the practice. F has a relative min at x equals 1. And that would be the end of my answer, but like I said, I'm doing the justification because f prime changes negative to positive. Once again, don't add more words to this. This is perfect the way it is. It is concise and it is complete. and it doesn't say anything wrong and it doesn't say too much. So just have that and stop. Okay. Number 4, find relative extrema. Once again, we are looking for places where the derivative changes signs. Extrema means max and min, so we're looking for both of those. All right. Whoops. Okay. So f prime is 3x squared plus 6x minus 9. Setting this equal to 0, I'm going to divide everything by 3 to make the factoring easier. So that's a 2, that's a 3, and that's gone. So I have x minus 1 times x plus 3 equals 0. So x equals 1 and negative 3. Okay, so those are our critical points. There's nowhere where the derivative doesn't exist. It's a polynomial. So we are doing test points on the number line around negative 3 and 1. Please make sure that when you draw your number line, you have the smaller number to the left and the bigger number to the right. Okay, otherwise you're going to have issues. All right, so signs of the first derivative. And once again, if I have this factored form, that's a lot easier than plugging things back in here. Because in my factored form, all I care about is the sign, meaning I can just say, is this factor positive, negative? Is this factor positive, negative? What's my product? Okay, so something to the left of negative 3. That's going to give me a negative here and a negative here, so I have a positive product. In between negative 3 and 1, this is still negative. This factor has switched to positive, so now I have a negative product. And then if I move from the left to the right of 1, this factor changes signs, and that one is still positive, so we have a positive. Okay, so we have two extrema. We have a derivative that is changing from positive to negative, so I drew positive slope to negative slope, and here from negative to positive. So I can see that f has a max at x equals negative 3 and a min at x equals 1. Once again, this doesn't ask for any justification. If it did, I would say on the max, I would say because f prime changes from positive to negative, and for a min because f prime changes negative to positive. And once again, I'm referencing the function that I'm using, which is f prime. Okay, one more here. So this is the graph of a derivative. Okay, the derivative of g is shown. Let's label this. This is g prime. And it says for which value or values of x does g of x have a max or a min? Okay, so once again, a max is when the derivative changes from positive to negative because we have a positive slope then a negative, and a min would be negative to positive. Okay, so what's happening? We have critical points when the derivative equals 0, which is at negative 3, negative 1, 2, and 4. All right, at negative 3, what's happening? At negative 3, our graph, the derivative is changing from negative to positive, so that's going to be a min. I'm just going to label it here and then I'll write it over there. And then at negative 1, our derivative changes positive to negative. That's going to be a max. Here, we are not changing signs. Okay, and then so this is neither a max nor a min. Here, the function is decreasing and then it flattens out for the briefest instance and then it continues decreasing. So we have it pretend like it's going to turn around, but it does not. So that is not a max or a min. And then lastly here, we're changing from negative to positive. Negative to positive is another min. So let's go ahead and write what we've got here. So G has a, let's see, we have one max. Okay, has a max at x equals negative 1. And again, I'm going to go ahead and do the justify. Oh yeah, it says justify. Okay, so x equals negative 1 because G prime changes from positive to negative. And then I'm going to say G has a min, forgot a min at x equals negative 3 and 4 because G prime changes negative to positive. Now, that is perfect. That is complete for our question. Sometimes we will have a free response question. Like this would be a perfect example of a graph that is given, and one of the parts might say, list the critical points, indicate whether each is a max, min, or neither, and justify your answer. If that was the case, we would need to add, we would need to add that G has neither a max or min at x equals 2 because G prime doesn't change signs. Okay, again, this question did not ask for that, but that is a really good example of something that does come up on a free response question.